f a function defined over R by fx equal x plus x e to the minus x. C is its representative curve in an orthonormal system, unit to centimeter. Calculate limit as x tends to plus infinity and verify that the line D of equation y equal x is an asymptote to C. Limit fx as x tends to plus infinity equal plus infinity into infinity. E to the minus infinity 0 is indeterminate. I put e to the minus x in the denominator. Limit as x tends to plus infinity of x plus x over ex. Hospital's rule هذا البارت only. So it is equal limit as x tends to plus infinity. Hospital's rule بتصير 1 over ex. 1 over infinity is 0, we get plus infinity. To prove the line D of equation y equal x is an asymptote, we calculate the limit as x tends to plus infinity of fx minus y equal limit as x tends to plus infinity of x e to the minus x. See 0 times infinity. I put x over e to the x by putting e to the x in the denominator, Hospital's rule. So limit as x tends to plus infinity of 1 over ex equal to 0. Therefore, line dy equal x is an oblique asymptote to C at plus infinity. Now part B, calculate the limit as x tends to minus infinity and limit fx over x. Limit as x tends to minus infinity, we replace each x by minus infinity. We see minus infinity, e to the plus infinity is infinity. So minus infinity equal minus infinity. Limit fx over x as x tends to minus infinity equal plus infinity. For general science, this one means the curve admits a branch parallel to the y-axis. Part 2. Study the table of variations of f prime and deduce that f prime x is positive. Study the variations not of f prime. We have to find the second derivative and study its sign. fx equal x plus e to the plus x e to the minus x. F prime x, derivative of x, 1. U dot v, u prime, which is 1 times e to the minus x, plus v prime, which is minus e to the minus x times x. So 1 minus x plus 1. Second derivative, u prime v minus e to the minus x into 1 minus x equal e to the minus x into x minus 2. We solve it, it is equal to 0. Second derivative equal to 0. It means that x minus 2 equal to 0, x equals 2. So x, fw prime, f prime. 2, negative, positive, the sign of x minus 2. Decreasing, increasing. not necessary to determine the limit of f prime. Now we have to deduce that f prime is positive. Minimum f prime x is 0.86 is positive, means f prime x is greater than 0 for every x belongs to R. Since the minimum of f prime x equals 0.86 positive, means f prime x positive for all x belongs to R. Part B, prove that C has an inflection point to be determined. To find the inflection point, second derivative equal to 0. Second derivative is 0 at x equal to negative positive. I of coordinates 2 plus 2 e to the minus 2 is a point of inflection. Now to study the variations of f prime is positive. It is increasing from minus infinity till plus infinity. Part 3. Determine the coordinates of the point A on C where the tangent T is parallel to the line D. So two lines are parallel if they have the same slope. We say that slope-let tangent equals slope-let D. Slope-let D is 1, slope-let tangent is f prime. X minus 2 e to the minus x plus 1 equal 1. 1 and 1 simplified. 1 minus x e to the minus x 0. E to the minus x is always positive, so 1 minus x equal to 0, x equal 1. And f of 1 equal 1 plus e to the minus 1. This is A. To show the equation fx equal 1 has 1 root alpha, alpha between 0.65 and 0.66. F is continuous and strictly increasing. F is continuous and strictly increasing over 0.65, 0.66. F of 0.65 is 0.989 less than 1. F of 0.66 equal 1.001, which is greater than 1. So fx equal 1 has 1 root alpha belongs to 0.65, 0.66. Now to draw the line D and the tangent, line D of equation y equal x, it passes by the point 0, 0 and by the point 1, 1. I locate A, which is 1, 1.36, and I draw the tangent parallel to D at this point A. We can take particular points. For x equals 0, y equals 0, the curve passes through the origin, increases, tangent at A, then it goes near the oblique asymptote. The last part, 6, calculate in centimeter square the area of the domain bounded by C, the asymptote D, and the two lines of equation x equals 0 and x equals 1. The area between the curve and the line, we need to calculate this area. This area equal integral from 0 to 1 fx minus yd. It remains integral from 0 to 1 x e to the minus x. By integration by parts using table, I put here u is x, derivative del x1, derivative del 1, 0, e to the minus x, integral minus e to the minus x, e to the minus x. I multiply diagonal, so minus x e to the minus x, minus e to the minus x between 0 and 1, equal f of what minus f of 0. We get 0.26 units square, but unit is 2 centimeters. We get 1.04 centimeters square times 4. This is all.